Good morning, students. Welcome you all to this online lecture series on website design, the subject of your current semester. In the last lecture, we studied various concepts related to website design. So let's continue with previous discussion. So today in this online lecture of website design, we shall be covering various topics related to basic design representation. These are behavioral, structural, and data flow design representations. Now let's move to the next slide for the details of the topic of behavioral design. As you see in the slide, for better understanding of this topic of behavioral representation, we can further explore this topic in four major categories. These are basic definition of behavioral design, purpose of this design, the basic syntax, and after that we will study few examples. So let's explore these four in detail now. Now the first question comes to our mind, that what is behavioral representation? The definition says that the behavioral means what the design is actually supposed to do, means what it actually wants to perform. Now what is the purpose of this design? The basic purpose of this design is to achieve best functional performance. So we can say that this design is considered as highest abstraction level as compared to other models. What it means? This means that it provides highest freedom in representation. Now basic syntax of behavioral representation can be understood with this example of behavioral design. Let's go to the next slide. As you see on the slide, an example of AND OR logical circuit is shown, and the VHDL behavioral style is written over it. Here in this example, the VHDL code is implemented using the behavioral approach. Initially, the AND OR logic is declared in the entity declaration. Then ports are specified such as A, B, C, D, E, and G. Then entity is closed. Now architecture is defined with the logical expressions of the G. What is G? It is the final outcome of this logical diagram, which is shown at right. Then architecture is closed. In this way the behavioral modeling is done. Here we must keep in mind that in the VHDL, this behavioral model is widely used for the test bench designs, because the test bench design doesn't care about the hardware realizations. So this was all about this behavioral design. Let's move to the next slide for structural representation. As you see in the slide, again we can further categorize this topic into four configurations. First part, definition, then purpose, syntax, and examples. Now first question is, what is structural representation? The definition says that the structure means how the logic is implemented in terms of circuit or netlist. Now what is the purpose of this design? The basic purpose of this design is that in this style we provide idealized description of the hardware components. This means in the structural style or design, there is advantage because it provides efficient implementation of the circuit. This means the simulation of the inputs and outputs at specific gates can be easily done using this structural representation. Now let's study the syntax using an example. As you see in the slide, there is an example of VHDL code for full adder using structural design. As you see, there are three parts of this design. The first part is entity, then component, and the last is signal structure. As you see, the entity declaration is basically vector declaration of 4 full adders in bit form, bit vector form. Then component is defined, 4 inputs and outputs. For example, X, Y and C out, as you see in the diagram. Then last part, that is signal, shows the logic of 4 variants of the full adders. As you see in the diagram, it is FA0, FA1, FA2 and FA3. I hope you have now understood the topic of structural representation. Now let's move to the next topic of data flow representation. As we explored earlier, again this topic starts with the basic definition. Now what is data flow representation? The data flow representation describes the architecture of the entity without describing its components. Now what is the purpose of this design? The basic purpose of this design is that this is a concurrent style of modeling. What is the meaning of this concurrent style? It means here the order of statements is not important, as that was in the case of behavioral modeling, which we studied earlier. In order to understand its syntax, let's take an example of data flow representation. As you see in the slide, there is an example of conditional signal assignment using data flow modeling. Here we have written the code of multiplexer with the 2 inputs A and B, 1 select line S and 1 output Y. Initially, the library declaration is done, then entity is defined for mux. The architecture part covers the basic logic as shown for the final output Y. Now what is this Y? This is the logical combination of inputs A, B with select line S. As you see in the first slide of our today's presentation, there is fourth design representation also, which is called as hybrid representation, which is just the combination of these three, that is behavioral, structural and data flow representation. So with this, we conclude today's lecture. In the next lecture, as you see in the slide, we shall be covering various topics related to applications of VHDL. We shall explore this topic in 2 parts because it is a lengthy topic. There are many applications of VHDL which we shall cover. In the next lecture, we will cover 4 applications, that is combination circuit design, multiplexers, demultiplexers, encoders and decoders. And in the next lecture, in the subsequent lectures, we will cover the other applications. Thank you.